Hi everyone, welcome to a new video on long by Chron or longitude by chronometer. This question deals with the celestial body of planets. This is from Captain Subramaniam's practical navigation series, exercise number 19, question number 2, which is an unsolved question from the book. So let's get started without further ado. It's 1st of December 1992 on the ship and it's PM on the ship. So let's highlight the important bits and pieces here: the DR position, lat and long. The planet is Saturn in this case here. The sextant altitude is given to you. The chronometer error is provided to you. So is the chronometer time. The index error 1.3 of the arc is provided to you. The height of I is 14 meters and you have to find the position line and the longitude through which it passes, right? So very straightforward long by chron question here. So when you get the chronometer time, make sure that you solve the ambiguity of the chronometer here. So the given time is 12:18:33. Just add 12 hours to this. So when you add 12 hours to 12:18:33, you should ideally get 24:18:33. But we don't write 24, we write 00 instead of 24. All right, because there are not more than 24 hours. There is only 24. So instead of 24, we write 00. And then we apply the error. So if it is slow, you add to it. If it is fast, you will subtract. So we add the slow error in both the cases, we get the GMT. And then what we do is we find out the zone. In this case, the longitude is east, so the zone will be east. So we will be adding our zone to the GMT time. If it was west, you would have subtracted. Now, how do we find the zone? We divide the longitude by 15 and we find out the LIT, which is the longitude in time. So LIT has a relationship with GMT, where if you apply the LI to the GMT, you get LMT. But in this case, or the method that I use zone, because I convert the longitude in time, LIT in this case, into a whole number. So here the LIT is longitude divided by 15, 106 degrees 14 minutes divided by 15 is 07 hours 4 minutes 56 seconds. So it is so close to 7 that I round it off to 7 hours. And then I add the zone to my GMT because I am in east longitude. That means I am running ahead of GMT. GMT is behind me. The time at GMT is much behind me. I am ahead. So as soon as I write both the scenarios here, I will choose which is the correct scenario for ship's time. So the hint given to me is that it is PM on my ship. And so this is the scenario where it is PM. It is after 12 o'clock and the date is 1st of December. So I write that here. And that means the second case is of no use to me. And so if I'm 7 hours ahead of GMT and the time at GMT is 12:23:34, that means it is afternoon at GMT. So the date must be the same. So that is the GMT date and time I will highlight in my answer. Make sure that you use the GMT time and not the ship's time by mistake. Okay, so now that you remember the the GMT date and time, the 1st of December 12:23:34, let's get into the almanac and find out the values listed on the left side of the page here. So GHA, increment, V value, um, declination, D value, the correction values, let's find that out. So for 1st of December 12:23:34, we go into the nautical almanac. So here you can see it's 1st of December. This is 12 hours. And for Saturn, make sure you go into the column for Saturn. You can find out the GHA value, the declination, and at the bottom of the GHA column and the declination column is your V value and D value. Now, when you find out the declination value here, 17 degrees 43.2, look at how the declination is changing from 12 hours into the next hour, 13 hour. So it is decreasing. So that means the corresponding correction value that we will find for the D value here will be a negative number. All right, so declination, you have to see whether your declination is increasing or decreasing going into the next hour. So in this case, it is decreasing into the next hour. So remember the time is 12:23:34. So as you go from 12 to 13, your declination is decreasing. That means your correction will be a negative correction. On the other hand, the V value is 2.3 and it's a positive value. So when we apply the V correction to our GHA, which is 294 degree 14.1, it will be a positive number. So taking all these values, 2.3 and 0.1, and we know that the minutes and seconds is 23 minutes 34 seconds, we will go into the nautical almanac, the increments page for 23 minutes and 34 seconds. So this is 23 minutes and 34 seconds. So you can see here, if I zoom in, this is the increment for Saturn. It will come under planets, of course. 5 degree 53.5 minutes. And for the D value of 0.1, the corresponding correction is 0. And for the V value of 2.3, the corresponding correction is 0.9. Okay, so if I say zoom in, you can see. So you find out the V and D corrections from the same column. That's what it says at the top of the column, V or D, and then the corresponding correction value. So declination, although it would have been a subtraction, in this case, it doesn't matter because it's 0. It doesn't matter if you add or subtract, it will still be the same. And V correction will be 0.9, and it will be added because the V value was a positive 2.3. Increment 5 degree 53.5 is always added. So having known these values now, you can go back into the page where we were working out this question, and you can see these are the values I got. So I can put here 2.3, and this is a positive 2.3. So this will be a positive 0.9. So we add the values here. Declination again, it was 0, remember, for the D value of 0.1. So we found out. And here is the latitude which is given to you in the question. So you just write all these values down. Then we have the sextant altitude on the right side given to us in the question is 46.2.8, 21.8. The index errors given to us as off the arc plus 1.3. So you will add it. It's given to us. These values are given to us in the question itself. Then we will find out the dip or the height of eye correction for a height of eye of 14 meters. So you can write down the height of eye of 14 meters. This is not the correction value. This is the value that you will use to go into the tables to find out the corresponding correction value. 14 meters height of eye. All right, so we go back into the nautical almanac. We go into the first page of the nautical almanac where the corrections are given. So 14 meters height of eye. I can erase the previous workings so that you guys don't get confused. So here you go. So I will zoom into the height of eye table for 14 meters. 14 meters will lie somewhere between 13.8 and 14.2. So you get negative 6.6. So with that, we come out again and we go back. So we have negative 6.6 here, the dip correction. Once you get that, you get apparent altitude, and then you apply the total correction for Saturn. So remember the apparent altitude value of 46 degrees 16.5 minutes. So with that, we go back to the same page where we left the dip, and we come to the center here. 46 degrees 16.5 will be somewhere here. So for Saturn, there is no additional correction. Only for Venus and Mars, you have additional correction. So this is the value, negative 0.9. You will take this value and go back and start working here. So 46 degrees 16.5, 0.9 negative value, you get 46 degrees 15.6 as true altitude. Subtract it from 90 degrees, you will get the true zenith distance as 43 degrees 44.4 minutes. However, the next formula, you have to apply the true altitude. So cos of P equals sine of true altitude minus sine lat sine dec divided by cos lat cos dec. Now remember here, there could be a plus here or minus. Now how do we decide whether it's plus or minus? If lat and dec are same names, it will be minus. If lat and dec are different names, it will be plus. Now in this case, both lat and dec had the same name. Both were south. That's why I used minus. If one was north and the other was south, it would be a plus. So simply then put the values in of true altitude, lat and declination. Straightforward, put the values in, solve them in stages. Make sure that you check your values with the one that I am showing you on the screen. You should be getting the same values. Solve them slowly, steadily. These are the correct values. Cos P equals 0.69123. Shift cos inverse P equals 46 degrees 16.4. Now here, the tricky part comes in where students don't know whether this is P or LHA. So how do we determine whether this is P or LHA is by a drawing. So what do we do is that we draw a diagram. So you can just draw a circle and you draw the celestial Greenwich meridian like this, call it GM, celestial Greenwich meridian. And the first thing that you do is you plot the GHA. So the GHA that you calculated was 300 degrees 8.5. GHA is measured westward from Greenwich meridian. So west is to your left and east is to your right as you face the Greenwich meridian. All right. So you go westward from Greenwich meridian and you measure 300 degrees, which should be somewhere around here. Each quadrant is 90 degrees. So if I go round, this should be your GHA, 300 degrees 8.5, and this is where you draw your Saturn. All right, this is your Saturn, GHA Saturn. All right, so GHA Saturn is 300 degrees 8.5, and then what you can do is you can draw your longitude. So the longitude given to you in the question is about, that is your DR longitude, 106 degrees 14 minutes, and it's east. So what you do is you go eastward from your Greenwich meridian and you measure out 106 degrees 14 minutes, whatever was given to you, right? So you go eastward. Somewhere here will be you as the observer. This is your east longitude. Remember, this is your longitude, the one in red. This is 106 degrees 14 minutes. Now, what is your LHA? LHA is nothing but measured westward from from your meridian, observer's meridian, to the meridian of the celestial body. This is your LHA. Now here, if you measure it out, so you can imagine if GHA is 300 degrees and longitude is 110 degree, 106 degrees 14 minutes something. So the LHA, this angle here, should be about 46 degrees. Now if you ask me how, let me show you how you can measure out. All right, so ideally I don't want you guys to get confused. All right, so remember GHA is 300 degrees 8.5. So every quadrant is 90, 90, 90. All right, so every quadrant is 90. So we have 90 plus 90, 180. So let's say this quadrant is 90, then this quadrant is 90, and then this quadrant is 90. That is 270. That means the remaining of the angle here, this here to here, this portion here, this angle here will be how much? About 30 odd degrees. Not this portion, but sorry, not this portion. Not this portion, sorry guys, this portion, only this much. All right, so this will be somewhere around 30 odd degrees, right? 30 degrees 8.5. And if you think about it, your longitude was 106 degrees 14 minutes. So this quadrant is 90. That means this angle here will be about 16 degrees, right? So 30 plus 16 is 46 degrees. So you know your LHA should be close to 46 degrees. That means that P can be equal to LHA. Angle P is equal to LHA. All right, so see, I don't want to get into the nitty-gritties of it, but I'm sure you can find out the value of the estimated LHA here. But you see how I did it, right? So every quadrant is 90 degrees, remember that? Then you can measure out the angle. So if you roughly know it is about 46 degrees, so for 16 degrees 14 minutes or something, so 46 degrees, so you know that your P is equal to LHA. You don't have to subtract it from 360 to get your LHA. So you don't have to subtract P from LHA. You don't have to subtract P from 360 degrees to get your LHA. You can straight away use P as your LHA. So that is why your GHA will be subtracted from your LHA and you get the longitude. So when you subtract 300 from 46 degrees, you get 253 degrees 52.1 minute. Now longitude cannot be greater than 180. So what do? You subtract it back from 360 degrees and you get your longitude 106 degrees 7.9. Now when you subtract GHA from LHA initially, you get 253 degrees. Remember here your GHA is more than LHA. So if GHA is more than LHA, if GHA is greater than LHA, your longitude is west. So I have named it west. But because it is greater than 180, I have to subtract it from 360. So I will reverse the notation and I will call it east now. All right, longitude cannot be greater than 180. You know that already. All right, once you have found out your longitude, you just have to find out the position line. But before that, you have to find out the bearing or the azimuth. How do you do that? You find out A equals tan lat by tan LHA. So don't worry about P now, forget about P, use LHA. So tan lat divided by tan LHA, put the value of latitude here, put the value of LHA here. All right, and find out, ignore the negative sign. You get 0.55, you will name it north because LHA or sorry A is named opposite to latitude unless your LHA is between 90 and 270. Is your LHA between 90 and 270 degrees? No, LHA is 46 degree. So you will name it opposite to your latitude. So your latitude was what? Your latitude was south. So you will name it north. B, tan declination divided by sine of LHA. So put the value of LHA as 46 degrees 16.4 in both A and B. You know the declination value already. You will get 0.44. Ignore negative sign if you get any. and you will name it south because it is named same as declination. All right, A and B opposite names, so C will be A minus B. If A and B were same names, you would have added them up. So A and B opposite names, you A minus B, and C takes the name of the larger, which in this case is name of A. A is the larger value. Then tan azimuth equals 1 divided by C times cos of latitude. Put the value of C, put the value of latitude, 1 divided by C times cos of latitude. Remember to solve the denominator before you go ahead solving the rest, or use brackets in calculator. Make sure you get the same answer that I have. Azimuth equals tan inverse of 10.48988, or azimuth equals 84.5 degrees. I normally ask my students to round off the number, but the exact answer in the book is 84.5, I think, close to that. So it's up to you. And then you have to name your azimuth. So how do you name your azimuth? North comes from C, name of C. Your C was north, so it's C. And west comes from where? LHA. So what is the rule for LHA? If LHA is between 0 to 180 degrees, LHA is west, which is the case here because it is 46 degrees. If it is greater than 180 degrees, LHA will be east. Here, of course, it is west because LHA was 46 degrees. So north 84.5 degrees west means what? It means that if I am in north, which is 360, this is north, and I am going west, which is 270, I am going 84.5 degrees towards west, which is almost here, you can say here. So how do you find out this value? It's 360 minus 84.5, which is nothing but 275.5. All right, that is your true bearing. So that is your true bearing here, 275.5 degrees. Now, how do you find your position line? Just add 90 and minus 90. So if you add 90 to 275.5, what do you get? You get 365.5, but nothing can be more than 360. So you will subtract it from 360 degrees and you get 005.5 degrees. And if you subtract 90, you get 185.5. So your position line will be in the orientation of 005.5 degrees to 185.5. Or if you have been rounding off everything, you can round it off to 275 or 276. And then you will have 005 to 185 or 006 to 186. All right. So I hope this video was useful and you have been learning how to solve long micron questions. You have understood this diagram, which becomes very important to determine whether it's P or LHA. Make sure you watch this video multiple times to get the concepts so that you are very clear when you go into the exam. Thank you for watching today's video. Please like, comment, share, subscribe, and let me know in the comment section whether these videos are useful or not. That is the least you can do to help me out here, guys. All right. And the Hindi description of this video, the link to that is in the description section below, and I will be releasing that public as well. All right. See you soon, guys. Bye for now.